Hello SolidWorks enthusiasts. Welcome back to the 3D Mechanical Design channel. Today we're working on CSWA Practice, Level 3, Task 3.2. If you'd like to follow along, you can download the 3D model using the link in the description below. And if you find this tutorial helpful, make sure to like the video and drop a comment. It really helps the channel. Let's jump in by quickly reviewing the key details of this task. We're working in MMGS units, and this exercise focuses on global variables and sketch patterns level 3, which are very useful for controlling repetitive geometry efficiently. For this model, you'll mainly use line and centerline tools, sketch patterns, extruded boss. The origin is located at the center of the lower front surface, so make sure your initial sketch is positioned correctly. That will save you time later. Here's an important tip. We'll be using a linear sketch pattern to create the veins, which is much faster and cleaner than drawing each one manually. Also, once your model is complete, the final volume should be 98,479 cubic millimeters, so you can use that to verify your result. Now let's break down the modeling strategy. The part is symmetric about a vertical centerline, so we only need to sketch one half, specifically the right side, and then mirror it to the left. This approach keeps your model simple and fully defined. Next, notice that there are 6 identical veins on each side. Instead of drawing all of them, we'll sketch a single vein. Use a linear sketch pattern to create the 6. Then mirror to the left. I think this is the most efficient way to build the geometry. Alright, that's the plan. Let's get started. Go ahead and open SolidWorks. Alright, let's start by confirming the units are set to MMGS. Next, go to the front plane and begin a new sketch. First, draw a vertical centerline starting from the origin and set its length to 5 millimeters. This will be our main reference. Now add a horizontal line, 1 millimeter long, positioned above the origin. Make sure it's centered on the top point of the vertical centerline. From here, we'll sketch the first vein on the right side. As you build the profile, make sure that the bottom points are aligned horizontally. This is important for keeping the geometry consistent. Now go ahead and fully define the sketch using the dimensions from the drawing. Once everything turns black, we know it's fully constrained. Next step, let's calculate the vein pitch. To do that, measure the total distance from the leftmost point to the rightmost point of the vein. Set the measurement precision to something high, up to 8 decimal places, so we get an accurate value. Now we'll use the linear sketch pattern tool. Set the pitch to 5.14446676 millimeters. Set the quantity to 6. Then select the vein entities to pattern. Once that's done, use the mirror tool and mirror everything about the vertical center line. Perfect, now all the veins are created. Next, let's complete the outer profile. Let's draw a horizontal line through the origin. Add a coincidence midpoint between the line and origin. And extend it so that its endpoint touches the side edge of the vein geometry. Then add 2 inclined lines on both sides to close the shape. Once the sketch is fully defined, use Extruded Boss and set the depth to 80 millimeters. The origin placement should match the drawing so everything lines up correctly. Finally, let's verify the result. Go to the Evaluate tab, Mass Properties, and check the volume. You should get 98,479 cubic millimeters. If you do, your model is exactly correct. If this walkthrough helped you, don't forget to like the video and support the channel. Thanks for watching.